Welcome to gradscompeer. In this video, we will learn very important aspects of resultant force, such as under what conditions a resultant force is formed, what is a resultant force, and how to find its magnitude and orientation. Let us take an object resting on a horizontal surface. The weight of the object is 2 Newton directed downwards, and the surface on which the object is resting will offer a reaction equal to 2 Newton in the upward direction. As the action and reaction forces have same magnitude and acting opposite to each other, they cancel each other. These forces are balanced along y direction, and the net force or the resultant force along the y direction will be equal to 0. Now let us consider two more forces whose magnitudes are equal and they are acting opposite to each other. These forces also cancel each other and the forces are balanced in x direction, and hence the net or the resultant force along the x direction is also equal to 0. When the forces are balanced in all directions, the force system is said to be under equilibrium. Now let us consider another case. Here the forces are balanced in y direction and the net force or the resultant force is 0. Now let's say there are two forces, one is 5 Newton, other is 3 Newton, directed opposite to each other. These forces are unbalanced forces along x direction. Although they are acting opposite to each other, they are not equal in their magnitudes. Hence the net force or the resultant force in the horizontal direction is 5 minus 3, that is 2 Newton. So when there are unbalanced forces in any direction, there exists a resultant force in that particular direction. In this case, the magnitude of the resultant force is 2 Newton. If we assume that the surfaces are smooth and there is no friction force existing, then the 2 Newton force will push the object in that particular direction. In this case, we have observed that there is a resultant force of 2 Newton in x direction and the resultant force in y direction is 0. We can indicate the resultant in x direction as Rx, which is 2 Newton, and this can be called as x component of the resultant. And we can indicate the resultant in y direction as Ry, and this can be called as the y component of the resultant. Here we can learn two things about any given force. If the force is situated along x-axis, its vertical component will be 0, and if the force is situated along y-axis, its x component will be equal to 0. In this case, it's a resultant force, but this principle is applicable for any given force. And if the force is neither parallel to x-axis or y-axis, but it is inclined with respect to one of the axes with an angle theta, then it will have two components. One is x component, other is y component. Now let us understand another aspect of the resultant force which is very important. Let us consider an object resting on a surface acted upon by three forces, and let R be the resultant of these three forces. These forces acting on the object will produce an effect on the object, and let's say that these three forces move the object a distance of 2 meters in 1 second. That is the effect of these forces on the object. And instead of these three forces, if we apply a single force, that is R, that is the resultant of these three forces, then that resultant force will also move the object a distance of 2 meters in 1 second. It means that the effect of applying three forces on the object and application of single force R on the object is the same. Now we can define the resultant force with two important points. Number 1, resultant is the net effect of all the forces. And number 2, all the forces can be replaced by this one single force and the system will have the same effect. Now let us see how to find the magnitude of the resultant force. Let us consider an xy axis, and these are the given forces. First, we need to resolve them into rectangular components. To know how to resolve the forces, please find the link of the videos in the description below. So after resolving the forces, we need to simply add the magnitudes of these components to get the x and y components of the resultant. So what are the vertical components here? Plus fx, plus py, minus ty, and minus qy, isn't it? And what are the horizontal components or the x components? Plus fx, minus px, minus tx, and plus qx. By simply adding the magnitudes of vertical components, we get the magnitude of vertical component of the resultant Ry. And by adding all the horizontal components of the forces, we get the x component of the resultant Rx. And in order to find the magnitude of the resultant force, we have the simple equation R is equal to root of Rx square plus Ry square. From this we get the magnitude of the resultant force. Now how to find the orientation of the resultant force or the angle which the resultant makes with the axis? Let us assume that The horizontal component Rx is directed towards positive x-axis and vertical component Ry is directed towards negative y-axis. And according to parallelogram law, the resultant is formed in the fourth quadrant. Let us say the angle of inclination is theta. Now we can take tan theta, which is equal to mod Ry by Rx, or theta is equal to tan inverse Ry by Rx. From this we get the value of angle theta. Remember here that we are taking only the positive values of the magnitudes of the components of the resultant force to find the angle theta. So that's all in this video. Thanks for watching. See you in my next video.